Okay, we are going to look at being given a vector and finding the angle that this vector is in a counterclockwise rotation away from the x-axis. So how do we find some idea of a vector's angle given that we just have basically these components of the vector? So one thing you could do is you could do a quick sketch to see where this vector even lives. So draw a quick xy axis. We're going to go 3 in the x direction, 7 in the y direction. So we have a vector that looks something like this. We want to know what this angle is here, some angle theta. So this is the formula or the rule that we're going to apply here. If I want to know this angle, I'm going to take the inverse tangent of b over a. What is b over a? Label these in alphabetical order, a, b, and then we're just going to substitute those in. So the missing angle that we're looking for is going to be tan inverse of 7 over 3. And then you want to grab your calculator and you're going to come up with an approximate angle value. Make sure that you are in degrees if the question specifying degrees, or radians if you are being told that you need a radian measure. Verify your question, verify your calculator setting, give an answer. If you're unsure, clarify with your teacher or professor, whatever you have, on what kind of answers or answer format you're supposed to have. For this video, I'm going to use degrees. All right, so we get approximately 66.8 degrees. And we want to take a look back at the sketch that we drew. Do we believe that this is approximately 66.8 degrees? Even if you draw a really rough graph like I did, we should be able to see that the bulk of the angle between the x and the y-axis is taken up here. So about 2/3 of this is the angle we're looking for, and that corresponds to 66 degrees. So I think we're good here. Let's take a look at another vector u down here. First of all, again, I'm going to draw a quick sketch so I know where this vector lives. So we're going to go -3, -5, and so my vector is down here in the third quadrant. And so we are looking at this rotation. We start at the x-axis, rotate counterclockwise, and we stop here. So this is going to be a big angle. We should expect that the angle that we find is larger than 180 degrees, because if we stopped from x-axis to x-axis, we have 180 degrees, but we've continued on beyond. And so whatever our answer is should be larger than 180 degrees. So let's see what we find. Again, we're going to apply the same formula. So theta is equal to the inverse tangent of b over a. And if you want to go back in, we can label these alphabetical order again. I'm going to have -5 divided by -3. So we should see that this is going to be a positive number in here. And you're going to plug that into your calculator and see what kind of an answer that you get. And so my calculator tells me that this is approximately 59.03 degrees, or 04 if you round. The next number after that's 6. So we're going to go with 59.04 degrees. This is definitely smaller than 180 degrees, so what happened? Notice that I said this was the same as if I did 5 divided by 3 because the negatives cancel. So what this is telling us is it's the same as going 3, 5 and having this vector up here. So this angle is again this angle here, which is also this angle here. They're vertical angles. And so to actually get the angle for the vector we need, we're going to take this and add 180 degrees to that, and the combination of that will be the entire rotation from the x-axis all the way around. And you can see from here to here is 180 degrees, and then add this 59 degrees onto that, and we will have our final answer. So for our final answer, we're going to have 239.04 degrees. And if you know that it takes 270 degrees to get down here to the y-axis, you know this number should be less than that, so you can kind of check yourself there. So this is our final answer. Cheerful Calculations.